All right, good morning, ladies and gentlemen. Welcome to week 12 of SAT Math Prep. I again am Mr. Wills, and I am your video instructor for this week's lesson, which will cover systems of linear equations. Now, we've done this topic before, but we're doing it again to sort of ease ourselves back into second semester here. Please make sure that you are correctly writing your name, first and last name, on the name line, and that you're circling any class you are in and any teacher that you have. You might have more than one. If you've got more than one, feel free to circle more than one there in those boxes. Now, we've been through this a couple weeks now. We ought to be in decent shape. So again, the big change is that we're now doing the notes separate from the practice. So please make sure that you take these notes and that you write down all of the work that I show here in the video so that you have good notes to use when we get to the skill check and you have the ability to use them to help yourself out. So all of these questions are former SAT questions. They're all directly off of an SAT, which includes the answer choices, which makes this extremely valuable preparation for the SAT because these are the kinds of problems you're going to see. All right, so example 1 says, in the equations below, B and C represent the price per pound in dollars of beef and chicken, respectively, X weeks after July 1st during last summer. So we got these two equations here. B equals 2.35 plus 0.25x, and C equals 1.75 plus 0.40x. Those equations, B represents the cost of beef per pound, X weeks after July 1st, and C represents the cost per pound of chicken, X weeks after July 1st. So X is weeks. B and C are both dollar amounts. Then we see the actual question that we are asked, which is, what was the price per pound of beef when it was equal to the price per pound of chicken? So right away we should think to ourselves, oh, well, that means we're supposed to set B equal to C. We're supposed to carry out substitution on this system. So we say, okay, 2.35 plus 0.25x equals 1.75 plus 0.40x. Now, we've taught you in the past that you need to clear the decimal, but let's be honest, this is on the calculator portion of the test. And if you have a calculator, you don't necessarily need to clear the variable in order to solve this equation. We need to isolate the variable, which means we need to move the x to one side. So let's say that we subtract 0.25x from each side. While we're at it, we should also subtract 1.75 from each side of the equation. So when we do that, that will move the x to the right side of the equation. 0.4 divided by minus 0.25 is 0.15x. And on the other side, 2.35 minus 1.75 is 0.6. Then we divide each side by 0.15 to get x by itself. And when we divide by a decimal, we should expect the number to get bigger. So when we divide 0.6 by 0.15, we should be expecting a number that's bigger than 0.6. In fact, 0.6 divided by 0.15 is 4. So x equals 4. Now at this point, this is where we're supposed to go back and ask ourselves, have we answered the question that was asked of us? It says, what was the price per pound of beef when it was equal to the price per pound of chicken? So what we have right now is an x value. Well, x is weeks. So this is not dollars, this is weeks, which means this cannot be the answer. In fact, this is when the prices were equal. They were equal 4 weeks into this problem. So what we really need to do is we need to figure out the b value when x equals 4. So what we do is we take the b equation and we take this 4 and we plug it in for x. So that would be b equals 2.35 plus 0.25 times 4. And we feed that to our calculator. So 2.35 times 0.25 times 4. And we get did not type that in correctly. Let me try that again. There we go. $3.35. That would be the cost in or price per pound of beef when it was equal to the cost of chicken was $3.35. So again, SAT math, the first answer we find is not always the correct answer to the problem. Sometimes we need to do something with that number. In this case, we needed to plug it back into the beef equation to figure out the price per pound of beef. Okay, on to example 2. Example 2 is another very common SAT-style systems question. Essentially, instead of actually having to solve a system, all we have to do is write a system. Okay? So we got to read the problem. 2 types of tickets were sold for a concert held in an amphitheater. Tickets to sit, that's what that should say, sit on a bench during the concert cost $75 each, and tickets to sit on the lawn during the concert cost $40 each. Organizers of the concert announced that 350 tickets had been sold and that $19,250 had been raised through ticket sales alone. Which of the following systems of equations could be used to find the number of tickets for bench seats, B, and number of lawn tickets for lawn seats, L, that were sold for the concert? So in your equations down here, B and L are the number, not the cost, number of bench seats and number of lawn seats. So when we do this, we need to use that fact to write one of our equations. They sold a total of 350 tickets, which means one of those equations should be B plus L equals 350. So that eliminates choice C because that equation is not there. The other 3 all have that equation. Again, when we do the SAT, 1 or 2 of the answers should be relatively easy to eliminate, even if we're not 100% sure how to do the problem. From there, we need to use the cost information. Okay? We were told that bench seats cost $75 each. We were told that lawn seats cost $40 each. And we were given a total amount of money raised for ticket sales of $19,250. So the green number, 75, should be attached to the green variable, so 75 times B. The pink number, 40, should be attached to the pink variable, 40L. And then that would add up to the total ticket sales, or 19,250. So A is clearly nowhere near correct. And really, we should not think that that is correct at all because it doesn't even look like anything we've ever done before. Whereas B and D are examples of equations we have seen before. The correct answer is D because these have the numbers attached to the wrong variables. Your answer should be D. 75B plus 40L is 19,250 and B plus L equals 350. Okay, on to example 3. System of equations shown below has a solution xy. What is the value of x minus y? So in this case, what we are doing is we are solving this system of equations. Now this system has both equations in standard form, which indicates that this is an elimination problem. So your first step needs to be to set the problem up for elimination. So what I'm going to do is I'm going to set the problem up so that x will cancel. It doesn't matter whether you eliminate x or y, but I'm going to eliminate x. And to eliminate x, I need to have the same number for the coefficients on x in each equation, but one of them needs to be negative. So if I multiply the first equation by 3 and the second equation by negative 2, that will change these two terms into 6x and negative 6x, which is the goal, because then when I add the equations together, x will cancel. So when I do that, I get 6x minus 9y equals negative 42, because I have to multiply all 3 things by 3, and negative 6x plus 4y equals 12. Because I have to multiply all 3 numbers by negative 2. Now that allows me to add those equations together and eliminate the x values, because 6 plus negative 6 is 0. So that would be negative 5y, because negative 9 plus 4 is negative 5, equals negative 30, because negative 42 plus 12 is negative 30. Then I would finish solving for y by dividing each side by negative 5 to get that y equals 6. Once I know that y equals 6, I need to plug into one of the equations. And it doesn't matter which one. So here's the second equation, which I'm only using because 14 is kind of a number that I don't really want to deal with. What we do is we take this 6 and we plug it in for y. So that would give us 3x minus 2 times 6 equals negative 6. And we would solve that equation. So that would be 3x minus 12 equals negative 16. Negative 6. Not sure where 16 came from. That should just be a 6. Negative 6. So equals negative 6, Alright, and then we would solve that equation by adding 12 to each side. Which would give us 3x equals positive 6. And then we would divide by 3, and that would give us x equals 2. So, in a normal algebra class, we would be done because we'd have our answer in terms of x and y. But this is not normal algebra. This is SAT math, where we have to answer the question that was asked. What is the value of x minus y? So we go in here and we carry out that step. We figure out x minus y by plugging in x and y to that expression. 2 minus 6 is negative 4. Our answer should be C. All right, at this point, we have finished going through the examples, so you should have some nice completed notes to use to help you complete the skill check that your proctor is now passing out. Thank you very much, ladies and gentlemen, for your time and attention. Do the best that you can on the skill check and turn both the skill check and the notes into your proctor. Make sure your name is on both papers. Thank you very much for your time and attention.